Okay, so in a little bit, we're going to take a look at a question. But like I was saying, the one thing that really and truly plays the most important role in this particular process of simplification of algebraic statements involving algebraic fractions, it's definitely powers. So once you can identify a variable, distinguish it between the variable and coefficient, you should be able to work out or simplify these problems with ease. Okay, so just give me 1 second. I need to do something. Nice. Okie dokes. So we're gonna get started now. Okay. First one we're gonna look at, I'm gonna simplify the statement further than it should be, right? So the first one, let's say we have something, oh, this pointer dull. Yeah, don't mind me if I'm feeling kind of spaced out. I'm sorry. Today's one of the days was we kind of heavy, so yeah. All right, back to what I was gonna do. We're gonna take a look at an algebraic fraction, and we're gonna talk about a few things that we just discussed, so that way you'll understand how the whole process goes on. So we're gonna look at a very simple one, and then we're going to gradually get into the more difficult ones. So let's start with this one, right? It's a really, really simple one. I don't know how well you can see, right? But hopefully you can see that. So that's a squared over a. So like I was saying, in the early stages, we need to know how to identify variables, coefficients, and powers are going to play a role in here. Now, in this particular example, let me see if I can spotlight. Just give me a second, right? There we go. Awesome. There. So it's looking a little blurry on the screen on my side, but yeah. So we have a squared over a, right? To simplify this, let's talk. So to simplify this, what would you do? If I asked you to simplify this algebraic fraction, what would you do? Any thoughts? Hello? Anybody want to tell me what they think? Alaria, Carisha, anybody? It's really simple.
Miss Ilaria said cancel in the chat.
Oh, I'm now seeing that. Okay,
Yeah.
okay. I'm now seeing the chat. All right. So I'm seeing cancel, I'm seeing something like find common factors. So when you say cancel, Alaria, what's she canceling? Listening, waiting, anything. How do we cancel? What are we canceling? Okay, the A's. All right, fine. Works fine for me. So if we're canceling the A's, what should I remain with? Okay, so, all right. You know what I hate to see the most? IDK. No. As of today, it have nothing like IDK. You're not going to tell me I don't know and then give my answer. You're going to tell me an answer. It's either you know it or you don't know it. No IDKs anymore. So I'm going to give you all some options and you'll tell me what is the correct response. So we have Ilaria's answer of A? Will we have 2? Will we have 1 over A? So of the 3 options, which one looks correct to you? Is it A, just a single A? Is it going to be 2? Or is it going to be 1 over A? Which one is it going to be? Okay, so Ilaria says 1 over A. Carisha, what is your input? What do you think?
A 2.
Okay, so Carisha says 2. All right, so I have a third person in here, right? You want to give me a suggestion? Who might the third person be? I'm quite curious, but yeah. So I have 3 different answers so far. 3, right? Ilaria changed her answer. Carisha says 2. All right. So here's the answer, and here's why the other 2 answers are not the answers that will give us the actual response for this. Notice something, right? So we have A squared over A. A is raised to the power of 2. A is raised to what power? The one in the denominator is raised to what power? Anybody want to tell me what is the power A is raised to? Okay, so Ilaria says power of 1. All right, cool. So yes, it is the power of 1. So anytime we see a variable standing by itself, coefficient is understood to be 1 as well as the power is understood to be 1. Now, what's another way of writing A squared, people? There's another way to write A squared. Anybody? Right, A by A. So I'm going to change it out to that, right? So A by A. My denominator is just going to remain as A because it's just a single A raised to the power of 1. Now, as you were saying, Ilaria, you're going to cancel. What we're canceling is a factor of A, because you notice that A times A gives me A squared, and then we have A in our denominator. So we can see that our term in our numerator and denominator have a common factor of A. And this is what cancels off with each other, a factor of A. Now what remains is just simply one factor of A, and we write, so this is A raised to the power of 1, which is just like what we had here, and that is our answer. Now, tell me something. Do you think you could utilize what I just did here to help you with simplifying other algebraic expressions? Just that simple one little thing that I just did. Do you think you'll be able to utilize that to solve some other algebraic fraction problems? Hold on like 2 minutes. Okay then, Carisha. Okay. Moving along, I'm going to put another I stepping out for some time. Okay. All right. So let's just continue where we were at, and hopefully she'll be able to catch up with us. All right. So let's say we had 2 variables instead now. So let's say we had something like this, right? Okay. So we're not expecting to hear from Ilaria. But Krisha, what do you think we should do here? Okay, Addie K. Let's begin. 1. First things first, notice this time you have a coefficient in both of your algebraic terms. Next, you have two different variables. So we have a raised to the power of 2 and we also have b. So in this first term in the numerator, we have a raised to the power of 2, we have b raised to the power of 1. Now in our denominator, we have coefficient of 4, we have a raised to the power of 1 and b raised to the power of 2. Notice the two things that I noticed, right? One is that we have common variables, so you notice we have a's and we have b's. Notice as well the coefficients, they also have a common factor. So this is how you're actually going to simplify it. You're going to utilize the fact that coefficients have a common factor, and as I just showed you, you can simplify algebraic fractions and algebraic terms by using this simple knowledge that when you have something raised to a power, it means you're multiplying that term by itself that number of times. So what I would suggest you do until you get the hang of how to do these things, we're going to write out the expression. So wherever we see squares, we're going to write it out as a product and see if that helps us with being able to simplify our expression. So in the next step, what I'll do is write 2a squared is a by a, and b raised to the power of 1 is just b by itself. And then I'm going to repeat the process. Now in the denominator, so it'll be 4 by a by b by b. So it'll be like this. Okay, there we go. So that is what my expression looks like. And the reason for doing that is just so that I'll be able to easily see where I have common factors. Now, Karisha, can you identify any common factors in these two expressions? Identify a common factor. Okay, so you see A. So let's cancel out A. So that's a start. When we cancel off A, we're canceling off a single A from our numerator and a single A from our denominator. Do you notice any other common factors? B. So we cancel off a B in the numerator and a B in the denominator. Anything else has common factors? Any other common factors you notice? 2 into 4, precisely. So we're going to cancel off a factor of 2 from here and a factor of 2 from here. 2 into 4 will leave me with 2. So now let's actually see what we get. We don't have a coefficient that is greater than 1, so let's look at the variables. We only remain with an a. Notice that we only remain with this a here. So in my numerator, I have a with a coefficient of 1. And in my denominator, I have 2 multiplied by b. So I have a 2b remaining in my denominator. And that's how we simplify our algebraic fraction here. Now, we're going to do another one. And again, we're going to increase the number of variables and probably increase the value of the coefficients this time. But the key principle behind it is simply identifying common factors between your terms so that you can easily cancel off any common factors in your expressions. So we're going to get started with this next example. So we're going to try this one. So you can write it down. It's 14x cubed y squared in your numerator, 14x cubed y squared in your numerator, and in your denominator, 7x squared y cubed. All right. So numerator 14x cubed y squared and denominator 7x squared y cubed. So I'm going to pull up the whiteboard on Zoom, and when you all are ready, good. And when you all are ready, you're free to draw away the solution for us, okay? So don't mind my handwriting, please. All right, so as soon as you're ready, you're more than welcome to join in and just put in your own answer. All right. Okay, so I see somebody put 2y on 1y. Okay. So everybody welcome to put an answer. Who knows? Everybody might have a different answer. So we could see how we're all managing. Come along, peeps. Come along. Don't be shy. Okay. So can I get one more person to be willing to share what they got? Yay or nay? All right, so that's Carisha. All right, Ilaria, come on to the board with you. At least this whiteboard a little different, it's a little bit more interactive, right? It's not just a set of working on the board. Oh, wow. Where? I didn't check the chat, so I don't know. I didn't say anything in the chat. There's nothing in the chat, man. Okay, so you both agree it's 2y on 1y. I wonder why. But wait, there's more, Ilaria. Oof. Time to erase your scribble. Oops. Bye-bye. Okay, here's how we actually work this out. So pay attention to what we're about to do. Don't mind the doors. All of them decide to talk now. Ugh, okay. So let's get started. So we have our coefficients. I'm going to write out the product for x. I'm going to write and be muted for a while, okay? Okay, so the noise has subsided a little bit. Let's talk about why the answer is this and not what you had before, all right? So let's get started. First of all, notice, oh wait, where did it go? Okay, first of all, notice that, right. Notice we have a common factor of 7 between our coefficients. So we have a common factor of 7 that can go into 14. So 7 into 14 will leave me with 2, while 7 into 7 leaves me with 1. We all okay so far, right? Remember what I was saying, the process just really and truly requires us to be able to identify common factors. So what we're doing here is cancelling down the common factors. Now, if you notice, right, the reason why I chose to use different powers now rather than just like an x to the power 1 and an x to the power 3, that kind of thing. So you'll see that in algebraic terms, sometimes you'll have a variable that is raised to a power being a common factor in another algebraic term. For example, inside x cubed, right, which is this x by x by x, you'll notice that there is an x by x, which is x squared. So within the x cubed algebraic term, there is a common factor of x squared. So for me, what that means is that I can cancel down an x squared from my numerator and denominator, which would look like this, canceling down x's in the numerator and denominator. Now, like I said, because there is a common factor of x squared between my numerator and denominator, that's the reason why I only cancel down 2 x's, because that is what will give me the x squared. And I did not cancel down anything else. So far, Carisha's answer of 2x in the numerator looking a little plausible. So we'll continue. So she'll get a little motivation, a little determination to put her answer and to feel a little more confident in what she's doing. So let's look at y's now. So I realized I can't cancel down any more x's. There are no further common factors in terms of x. So moving to my next variable. In my numerator, I have a y by y, and in my denominator, y by y by y, right? So I have y squared and y cubed. And just like with the x cubed and x squared is an algebraic factor of x cubed. So in the case of the y's now, y squared is an algebraic factor of y cubed. So I'm going to cancel down y squared from numerator and denominator. So canceling down a y and a y, a y, and a y. And that means I'll remain just with algebraic term y in my denominator. So what remains is what will constitute my simplified algebraic expression. What that gives me now is that my numerator is 2 times x, which gives me 2x. And in my denominator, what remains is, well, we'll call it 1 by y, which will leave me with y. And that's our answer. So, Carisha, do you feel a little better about your answer? Yes. Okay, I said the first y, 1y thing. Okay. All right. So, I'm going to give you another one to try out in a little bit. But for the moment, do you have any questions about how we did the simplification here? Yes, no, maybe, anything? Okay, you're good. All right. The joke's at about. Just give me a minute. I still cannot write in cursive anymore. Well, especially on computer. Anyway, so I'm going to clean down the board now. Okay, so I'm going to put another example up for y'all, and I want you to try it out, okay? I didn't even realize time flies so fast. We only have 10 minutes remaining. So once you understand this basic concept here, you can apply that to absolutely any other problem involving multiplication and division of algebraic terms. So I'm going to write one down, you write it down, and let's see if you can solve it within 2 minutes, okay? So get ready for this one. So your first problem, all you need to do for me is simplify it. Simplify and my apologies again for handwriting because I would prefer to type it so it's a bit more legible, but it was a little impromptu session and it's just kind of like on the fly. All right, let's see who gets this one out. You have 2 minutes starting now. Okay, so let's see. Any thoughts? So I saw some thoughts coming together, but anything else?
I'm confused.
No, you're not confused. To be honest, you're just missing out something. You have the majority of it correct. Well, had the majority of it correct. There's just one tiny piece that you're missing. So I want you to take a look back at it and see if you can figure out what is missing. So the B in the numerator is correct. Y in the numerator is correct. The A in the numerator is correct. But take a closer look at your terms. And if you notice, you missed an entire variable. Does anybody see it? Because everybody's responses thus far incorporated A, it had B, had Y, but I don't know what happened to this. So one more try before I put the answer. And as much as I don't want to like press too much into the next hour, we'll just do one more session because I have Form 5s in a little bit. So we'll do one more half an hour, well, 40-minute session and do some other questions with this. I feel like hitting you a book, Ilaria. Confused size? What is confusing? Let's start with that. You need to talk now. Unmute that mic and start talking. Yes, you are, Croatia. You are overthinking it. You have 75% of the answer. You're missing a 25%. So let's see. Somebody tell me. Of all the variables, I can't unmute what? Huh? It is kind of rude to do that now. How? What are you doing? What? What? How come? Okay. Or something. It's really been staring us in the eyes like from the very beginning. Everybody's answers had A, B, and Y. But what about X? Why was X omitted from everybody's answers? X is just as much a variable as everybody else. Excuse me? It's are you bullying poor X? Are they leave out X from everything? Gosh. So this is the reason why Carisha's answer was 75% correct. And the reason why Ilaria probably is thinking, oh my goodness, this is something I don't know, and whatnot and the other, and you all need to stop overthinking. So let's go. You have the ax cubed b squared, right? So if I wanted, I could write this entire numerator piece as one term if that makes my life simpler. But let's just do it like this. Notice something. You have a common factor of a in this numerator and this denominator. So when I cancel off a common factor of a, what remains in this denominator is a single a. Now look at something. What about x, guys? X cubed. We have a factor of x in this denominator here, don't we? Yes or no? Yay or nay? Something, say something, say something. Yes, thank you. Krisha. Cracking. X. We'll cancel the x, and x cubed has a common factor of x. So when I cancel off a common factor of x, what should remain there, guys, girls, ladies? What should remain? Tell me. The yellow a little too bright, but yeah. Tell me all. What will remain when I cancel off a factor? X squared. Perfect. There we go. So I'm going to write it down. X squared. Now look at something. You did this cancellation correct because there is a common factor of b in this denominator with this numerator b squared. So when I cancel off a factor of b, I remain with just a b. And y has nobody. So y is just all by himself, just cancel off with nothing. Now let's write our answer. Our answer is as follows. If you want, you can write the write the terms as they appear first and then rearrange them in alphabetical order. But if you're pretty fine with rearranging and putting them in alphabetical order first, no problem. So we're going to put our algebraic terms together. X squared by b will give me bx squared. So my numerator has bx squared. And in my denominator, I have y by a, which is y. So Carisha, you see why you were 75% correct? Yeah. So yeah, when it cuts off, give me like a 5 minutes because I'll just wait for the video to convert and we'll resume. We'll do some other questions with some